Welcome back to the Walnut.
Here we have figure number 1. The question is how many triangles are there? Okay, this is piece number 1 and this is 2. This is, take it as 3 and this one is 4. So piece number 1 and piece number 2. So that two pieces. It is not really triangles. But at the same time, this 1 and 3 together, it's a triangle. And same way, 2 and 4 together, that's a triangle. Same way, 1 and 2 together, it's not a triangle. But if you take 1, 2 along with 3 and 4, that's a triangle. At the same time, 3 alone is a triangle, 4 alone is a triangle, and 3 and 4 together is a triangle as well. So how many triangles we have? It is slightly different from what we have done. Previous questions, it was like triangles something like this way. Triangles which are partitioned as triangles. So that case, n into n plus 1 by 2. This case method is different. So what is the method for this question? Okay, let's count it. First, let's go for counting method. How many pieces, how many triangles we have? One piece at a time. If you take one piece at a time, 3 is a triangle, 4 is a triangle. So we have 2 pieces. Any other pieces? Not really. So 2. Then 2 pieces together, 2 pieces together. If you take any 2 pieces together, 1 and 3 it's a triangle, 2 and 4 is a triangle. So we have 2 such pieces plus 3 and 4 together. Those 2 pieces together it's a triangle. So we have total 3 pieces. So 3 and 1, 4 and 2 triangles. Then 3 and 4 together it's a triangle. So that is total 3 triangles. How about like if you go for 3 pieces? Any 3 pieces if you take it, it's not a triangle. 4 pieces. If you take any 4 pieces, 1, 2, 3, 4 together it's a triangle. Yes. So ultimately how many are there? 3 plus 2, 5 plus 1, 6. So 6 triangles we have here. And how about this case? This case again, if you mark it, this is what? 1, 2, 3, 4, 5, 6. And if you count it, let me write it over here. Somewhere here, that would be easy. T1, 1 piece. 1 piece at a time, we have what? 4 is a triangle, 5 is a triangle, 6. So we have 3 pieces. And 2 pieces together. 2 pieces together, we have what? 4 and 1 together is a triangle. 2 and 5 together is a triangle. 6 and 3 together is a triangle. So how many triangles we have? 3. So 4 and 1, 5 and 2, 6 and 3. So 3 such triangles when you take 2 pieces. At the same time, this 4 and 5 together, that's a triangle. 4 and 5 together. And 5 and 6 together, that's a triangle as well. So how many are there? 2 more. So 2 pieces together, we have 5 triangles. How about like 3 pieces together? Any 3 pieces? Let's check it out. 3 pieces together, is there a possibility? Well, if you take 1, 2 and 4, that's not a triangle. If you take 1, 4 and 5, it's not a triangle. But if you take 4, 5 and 6, that's a triangle. So 1 piece. And how about 4 pieces together? 4 pieces. 4 pieces together, if you take 4, 5 and 1, 2, that's a triangle. Then 4, 5, 6 and 2, 3, that's another triangle, right? So 2 of them. And 5 pieces together, it's not possible. And 6 pieces together, that means all the 6 pieces together, we have 1 triangle. So T6, 1. Well, ultimately, 3 plus 2 is 5, 5 plus 3, 8, 10, 12. We have 12. And next one, well, we can think about counting, but that counting must be time consuming. Right? So do we have a method for that? That's a question. Do we have a shortcut? Well, previous question, this is what we have. If a triangle is partitioned as small number of triangles, that means number of pieces, and each shape is a triangle, so we can use n into n plus 1 by 2. But in this case, each small piece is not a triangle. Well, some of them are triangles, small pieces are triangles, but all the smaller pieces are not really triangles. So that case, we have to go with this formula. That's an easy way of dealing with this. So what is that formula? Let's discover it, or let's find out what it is. N into k into n plus 1 by 2. So what is n here? What is k here? That's a question in front of us. Which one is n? Which one is k? Here, if you take this way 1, 2, 3, so that means so vertically we have 3 pieces, right? So 1, 2, 3 pieces this way. This is the vertical 1, 2. So this is, we have 1 piece, we have 2 pieces, we have 3 pieces. So that is n, 3. And horizontally, that means if you cut this way, how many pieces we have? This is 1 piece. So horizontally when you cut it, don't think about vertical cutting, just horizontal cutting. I may use another color for that. So this is the horizontal cutting, this one and this one. So if you cut it horizontally, how many pieces? 2 pieces. So k, we take it as 2 into n plus 1. So 3 plus 1, 3 plus 1 by 2. So what do you get here? 3 into 2, 6, and 4 by 2 is 2. So 6 into 2, 12. So exact same answer we got it here. So that can be used for the other figure as well. Exact same formula. So this is the formula, n into k into n plus 1 by 2, especially if you get a figure shaped like this. Okay, so what is the answer here? So this case, what is n? N means this way it is cutting. So this is what? Vertical cutting. Vertical cutting, 2 cutting, how many pieces? 3 pieces. 1, 2, 3. So n is equal to 3. And horizontal, how many cutting we have? This is 1 cutting horizontally, so we have 1 piece over here. This is second cutting horizontally, 2 pieces. And we have 3 pieces and we have 4 pieces. So 4 pieces. That means k is what? 4. And well, n plus 1, 3 plus 1, 3 plus 1 by 2. So solve it. So 3 plus 1, well, 4 by 2 is 2. So 3 into 4, it's 12. 12 into 2, 24 is the answer. So how many pieces we have here? 24 pieces. So this case, how many are there? Check it out. How many triangles? First figure is pretty simple. We have only 1 triangle. How about second figure? Second figure, we have, how many triangles we have here? So this one is a triangle. This one is a triangle. So this one 2, this one 3, this one 4. So altogether what? Is it 4 triangle? 4 triangles plus the large triangle. Is that 5 triangles altogether? Think about it. Is there any other possibility? So what is the answer? 5. Is that correct? So 1 piece at a time, 1 piece at a time, T1. 1 piece at a time, we have 4 of them. And well, 2 pieces at a time, is there a possibility we have a triangle, any 2 pieces together? So if you take 1 and 2 together, that's not a triangle, that seems like a parallelogram or rhombus. And well, 2 and 3 together, it's not a triangle. How about like 4 and 2 together, it's not a triangle at all. So it is a rhombus, so it doesn't work that way. So we have 2 pieces together, it's not possible. 3 pieces together, any 3 pieces together, does it give you a triangle? Not really. And how about like 4 pieces? 4 pieces together? Oh, 4 pieces together, we have 1 triangle. So 4 plus 1, 5. And how about this case? How many triangles will have? So that case, again, if you mark it like 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 small triangles. On the top of that, do you have a combination of 2 triangles? I mean 2 pieces together, is it a triangle? 3 pieces together, is it a triangle? Check it out. Here, T1, 1 piece at a time. 1 piece at a time, we have 9 of them. And 2 pieces together, any 2 pieces together, do we have a triangle? Any 2 pieces together? Is there a possibility of a triangle we have here? Not really. How about like 3 pieces together? Any 3 pieces together? Not really. How about 4 pieces together? Is it a possibility? Look at this. 4 pieces together, 1, 2, 3, and 6. That together is a triangle. See that? At the same time, we have 3, 4, 5, and 8. 3, 4, 5, 8. That's another triangle. Let me use another color for that. This is what it is. So 4 pieces together, we have 2 triangles. Is there any other 4 pieces together? Yes, there is. Which one is that? This one. See that? 9, 6, 7, 8. So that 4 pieces together, that's another triangle. So 4 pieces together, we have 3 triangles. So T4, that means 4 pieces together, we have 3 triangles. Anything more than that? 5 pieces together, is it possible? 6 pieces together, is there any possibility? 7 pieces together, is there any possibility? Not really. 8 pieces together, not really, but all the 9 pieces together, we have a triangle. So T9. T9, how many? 1. So 10 plus 1 is 13. So we'll have 13 triangles here. Third one. And about the fourth one. How many triangles? Well, we can count, but it takes time. See that? Even if it is 9 triangles, when we counted it, it took a while. So in that case, it's a time to uncover this formula, correct? So let's go for the formula. What is the formula? How do we apply the formula? That's what we are looking for. So it's going to be n into n plus 2 into 2n plus 1 divided by 8. So what is the n here? So look at this picture, look at this picture, what is n? So that's the first question in front of us. What is this n here? I'm pretty sure some of you have a pretty good idea about that. So how about the others? So this case, you know what? The n, we'll take it in such a way that n is the number of triangles which is kind of like facing upwards, or the base is here and the triangle, if it is facing upward, we count the number, how many triangles on this side, on the base. And that would be the same number of triangles here as well, doesn't matter because it's equilateral. So how many triangles we have? 2. So n is equal to 2. And in this case, what is n? How many triangles facing upwards? 1, 2, and 3. So 3 triangles facing upwards. So in this case, n is equal to 3. And in this case, n, how many triangles facing upward? 1, 2, 3, 4. Well, we are not really taking the total number of triangles facing upward. We are taking the number of triangles facing upward on the baseline. On the baseline. That baseline could be on this side, or it could be this side, or it could be this side. Doesn't make any difference. Equilateral triangle. And this method, this formula is applicable only for these type of triangles, equilateral. And here, how many are there? 1, 2, 3, 4, 5. So n is equal to 5 here. And n is equal to 4 here. Now we'll check out this formula. Does it work or not? So we'll try that n is equal to 2. So what we got here? 2 into 2 plus 2, that's 4. And 2n. 2n means, well, 2 into 2, that's 4 plus 1 is 5. By 8. So how much is that? 20. 20 into 2, 40. 40 by 8, we have 5. That is what the answer we got it here. So when we counted, we got the answer 5 as well. This one, when we counted, we got the answer 13. So let's check it out, the second one. If you apply the formula, do we get the exact same answer? Let's try this. Okay, so well, n is equal to 3. 3. And 3n plus 2 is 5. So 3 into 5. And 2n, 2n is what? 6. 6 plus 1 is 7. So ultimately, when you multiply it, 7, well, it is what? 3 into 5, 15, 15 into 7. 15 into 7 is 105. 105 by 8. Well, 105 is not a multiple of 8. So when you divide it, what do you get? You get, it is 13 point something. 13 point something, right? So in this case, we are not really taking what is after this decimal point. We are taking what is before that decimal point. So that is 13. So we get the answer 13 here. So this case, you know what? In order to avoid that decimal point, we can have 2 different formulas for odd number and even number. If n is an odd number, we can have a different formula. But that is, you know what? That's a bit confusing. Don't go for it. Just apply this one formula. And if you get a decimal point in the answer, you take whatever before the decimal point, that would be the answer. That means the integer part. Integer part would be the answer here. We don't need the decimal point. And look at n is equal to 4. What kind of answer we get? Let's try that. Let's apply the same formula for n is equal to 4. n is equal to 4. This is 4. 4 plus 2 into 6. Well, 2n. 2n is what? 4 into 2, 8. 8 plus 1 is 9. So how much you get? 6 into 4 is 24. 24 into 9. 24 into 10, 240. 24 into 9 is what? 240 minus 24. 240 minus 20? 220, right? So 216. 216 by 8. 216 by 8, how much you get? 216 by 8. 8 how many times? 2 times, right? And balance is what? 5. So 56. 56. So it must be 7. This part is 7. So ultimately what you get is 27. So how many triangles we have? 27 triangles. And apply the similar method over here. N is equal to 5. You get the answer for that as well. So this is the formula. Always remember, if you get a figure like this, n into n plus 2 into 2n plus 1 divided by 8, that would be the formula applicable for this case. Alright, let's go for next one. Here, how many squares are there in this picture? So take a look at that. It's not a regular case. If it's a regular case, we can apply the formula n square. So that means n square plus n minus 1 square plus n minus 2 square, etc. So if it is like 7 into 7, 7 by 7 matrix, you can go for 7 square plus 6 square, etc. We have tried that earlier. But this one is totally different. It is not a regular matrix. So that case, how do we find the number, how many squares are here? The method what we have here, it is not the shortcut method, but it is a counting method. How do we count it? Let's mark the pieces like this one, 1, 2, 3, 4, 5, 6, 7, 8. And this one mark it as 9, 10, 11 and 12. So 12 pieces. If 12 pieces, how many squares are here? All these pieces are not really squares, but some of the pieces, it's a combination of some of the pieces are squares as well. So ultimately, this is what the counting method, one piece at a time. That means one square. One piece at a time we have. 1 is a square, 2 is a square, 3 is a square, 4 is a square. So 4 small squares we have, 4. And S2, that means 2 pieces together. 2 pieces together, do we have any square? Of course, if you look at that, 4 and 6 together. These 2 pieces together, this is 4 and this is 6. So the 4 and 6 together we have a square. Same way 3 and 5 together we have a square. 1 and 9, that's together square. 2 and 10, that's together is a square. So we have 4 of them. Then 3 pieces together, S3. So 3 pieces together, well, if you take it this way, 3 pieces together, 3, 5, 7. There's 3 pieces together, 4, 6, 8. 2, 10, 12. 1, 9, 11. All these 3 pieces together we have a square. So 4 of them. Now any other square possible? 4 pieces together, any of the 4 pieces together? Well, this 4 pieces together, see that 1, 2, 3, 4. This 4 pieces together, that's a square. Next one. 8 pieces, that means 1, 2, 3, 4 and 9, 10, 5 and 6. So that means, I'll just draw it. This one. This is another square we have. Apart from these squares we have here, we have 1, 2 and the largest square as well. So how many are there? Total 3 more squares. So here we have 12, 12 plus 3. So total 15. So 15 squares are there.
If you need to have additional questions for practice, take a look at our website walnuttraining.org.